So, students, reconfirm me whether am I audible well and you can see me well. Hello. Yeah. Okay. In the last week, we did and complete the vernier caliper principle. I hope that all of you got the vernier caliper, your own vernier caliper, and only for 3 students I posted it today, including someone called Amaya, a Muslim boy. I can't remember his name. He just joined today, like Ashfan or someone, and another girl. I sent them the tute just today, so you will receive it by another maximum of 3 days because it's registered post. You will immediately receive, and all the others, I think they got the tute as well as this vernier caliper for you. So that theory is completely done. I'm pretty sure the worksheet was kind of really tougher level than you expected. Students. So the worksheet was like kind of tougher one than you expected, I'm pretty sure. Because the question number 19 and 20 and 18 were really kind of, yeah, like addressing to your next level of the thinking capacity. I'm going to discuss those questions today. I'm going to discuss those questions today. So now I'm going to start very new theory that is called screw principle. I just drop a message that you to find certain nut and bolt yourself, right? I ask you to find out the nut and bolt yourself if you can. If you can't, it doesn't matter because for some students, they are really used to use this type of screw and nuts. But some of the students, they have never unwind any kind of like tightened or any kind of nut or bolt. So this is called a nut. This is called a nut. Meanwhile, this one is called a what? Bolt. Today's lesson, we are just mainly focusing on an instrument called micrometer screw gauge. And we are just going to touch some parts of spirometer as well. Both of the instruments, measuring instruments, are working under the principle of what? Screw gauge. Screw principle. So this is the nut, this is the bolt, this mechanism. If you have a one, that's much better. And I also ask you to write clockwise and anti-clockwise divisions of 10, 20, 30, like until to 100 on a DVD. Only one student sent me doing that. She just completed drawing that on that. It is really good because this is all activity based. I need to give you the 100% knowledge because if I just show you an example, you just do it. That is going to be something like disastrous. It is almost like suicidal. Tell you what, because if I just show few examples, you are following me. If you find something really different, you will definitely not going to do it. And I included A-level structured questions, mainly based on micrometer screw gauge, spirometer, as well as vernier caliper. Why do they include those? Because are these things easy or hard? The main reason is these ones are kind of hard. If you are just following my instructions only, one day, once the theory knowledge pile up, you will definitely forget this. You can't do it. I don't want that to happen to you. That is why I'm feeding you with the basics. If you know the basics, You will never forget. You can write at any stage in the A level. Okay. If you found someone like this, something like this, it's much better. If not, even I am going to teach you screw principle first. And I'm going to discuss the questions in the later end of the class. I will definitely discuss those Vernier questions I gave you in the last week. If you had burning problems over there, I am going to give the solutions timeline between 11 to 11:30. From today onward, I will finish all the theory by 11. From 11 to 11:30, it will be question discussion session. You can ask me any question you found, and I will discuss. Is that okay for you? Because I think 11 o'clock is the best time to stop all the theory. Okay, keep that in your mind. Okay. First of all, I'd like to show you what is that instrument, micrometer screw gauge. This is what that instrument called, micrometer screw gauge. This 25 millimeter size one. That means that maximum measurable length is 25 millimeters. That means 2.5 centimeter. If you make maximum separation, that's going to be 2.5, no more than that. See, 25 is the last number written on it. Okay. Okay. First of all, going for this. What did you say? What did you say? Can you send me that message again, please? Can you send that message again? I just posted the tute related to this lesson only. I didn't post you the previous lesson one because all the tutes that I printed for the previous lesson are over. I posted the tute related to your this lesson. You are Prishan or someone or the one who recently joined. Okay. And the other instrument working under this principle is spherometer. Even though it looks like very big in the diagrams, it is a very small sized one. See, this is what it called, spherometer. It goes down. I will discuss all of these theory one by one. So firstly, write a very huge topic, not a big topic, huge topic called screw principle. What is it? Screw principle. Write it. Very big one. Screw principle. Screw principle. Okay. Now write the definition. For the new students, my older students, you know what is it? Whenever you write any definition in whatever your subject, it can be biology, it can be chemistry, it can be anything, even in combined maths, there are definitions. Write the definition with really distinguishable feature in with. The star sign is not a distinguishable. This is for important point. But definitions are way more than important, extremely important in physics especially. So I normally advise you to use like a hashtag or a dollar sign or something like this. I normally use these two for my definitions for my own education purposes. you should see the thing in one shot. Okay. Now put whatever the sign you would like, right? Put whatever the sign you would like. Write the definition. Uh, preparation of a scale. Preparation of a scale. Preparation of a scale. By dividing pitch length. By dividing a pitch length into capital N number of dividing a pitch length into capital N number of equal divisions in the circular scale. Okay. Now I would like to tell you what is this pitch. Have a good look at. I told you to find certain bolt like this. Now can you see these things we normally used to call like threads? What do we call? Threads. But in physics, we used to call the separation between these two threads as what? I told you the word. What is the word we call? The separation between two threads? Pitch. Yes, it is a pitch. Right. Now, firstly, draw a screw ball like this. I think I used the wrong pen. Screw ball and draw the threads. Right. The separation between two consecutive threads is known as X. That means pitch. Copy this into your book. Copy this into your book. Okay. Copy this into your book. Right. I think almost you had enough time. Now, right, as a definition, small definition, never ask. They never ask. But if you are curious to know, the separation between two threads, two consecutive threads, separation between two consecutive threads of a ball is known as pitch. So if you have a ball with you now, just try to move your finger like nail like this. You can feel it, right? The separation between two threads is known as pitch, right? This is the time for you to get your DVD. If you have, this is the time to you to find your DVD if you have. Okay, give me a 1 second. I'll bring my own DVD. Okay, actually these two are new DVDs, but it doesn't matter. I am going to draw you and show you, because if I had drawn it, you won't get really idea. That's why I decided to draw it over here in this class. I told you to draw separations like this. One mark, and the opposite side another mark. So this is the 0 line. Exactly other half is 50. So nearly 0, 10, 20, 30, 40, 50, 60, 70, 80, and only 90. Now I divided it into maximum of 90, no 100 marked. Why? The 0 line again becomes 100. Okay. Now let me show you a certain magic. When I fix this with the screw, when I rotate this into one cycle, see, exactly one cycle, it will come back to the original position, right? It will come back to original position, because you can see, now have a good look at this one only. When you complete each cycle, now have a rough idea about the length of this outside part. I will rotate one cycle. You can see the length increase. Again another cycle, length increase. Again another cycle, length increase. That means for one entire cycle, it will move one pitch forward. Can you understand? For each cycle, it will move one cycle forward. Can you understand it? Yes. Okay. Now you can freely rotate this. Huh? Now have a good look at. If you just rotate like this. Now see, only 10 parts came to the bottom. Now another 10, 20, 30, 40, 50, 60, 70, 80, 90, and another 100. Like that, as it rotates one cycle, the pitch moves to the length of the bolt, move forward or backward with what? One length of a pitch. Is there anybody who can't understand this? I will explain you, because if you catch this screw principle, we can finish all the instruments within today and the next day. Is there anybody who don't understand this screw pitch case? Yes. Can you understand this pitch thingy? So when it rotates one entire cycle, now there is no end come out. I'm going to move only one cycle rotated. You can see it has come out. Another cycle, another pitch length came out. Another cycle, another pitch length. So you have to understand, when it rotates by a one cycle, it will move forward or backward within a length of one pitch. Can you understand it? Say yes or no. Hey, yes. Okay. Now the thing is, that is the movement of the pitch. Remember one thing, the circular scale may have marked in the clockwise direction or anti-clockwise direction. I will only go with 50, 0, 10, so 20, 30, 40. Right. Have a good look at only 50 divisions. See, 10, 20, 30, 40, and 50. To what direction? You can see it is rotating in the opposite direction of where the arms of the clock rotate. That means it is anti-clockwise. Very important to understand this. I will tell you why. Anti-clockwise. It is anti-clockwise. Now the circular scale may have marked on the scale in the direction of clockwise. Have a good look. 0, 10, 20, 30, and 40. Now see, numbers increase in this direction. That means clockwise direction. In the clockwise direction. Now mark these two into your diagram. So write like the circular scale may come up in clockwise direction or anti-clockwise direction. I will tell you why. I will tell you why. But firstly, copy this. Okay. Did you copy? I only paused vernier caliper. Even for a vernier caliper, it costed like 700, but it is affordable from your class fee. But this one is, I bought this one at 4,700. How can I afford to cost you one micrometer screw gauge for each of you? This is not. But I have a program. In the end of this entire lesson, there will be a proper test. For the student who get best marks. I will post him or her 1 micrometer screw gauge personally. And for the second place, I will post sperometer. That is my original plan because I can't afford each student this much of expensive thing because your class fees is still 3,500. How can I afford that much? Even for the last month tutorials, it costed like 1,100 to 200 for each student. It doesn't matter. It is affordable. Right? I have this plan. So try to get the maximum mark. And there is a benchmark as well. So the first place even should get above 90. That is the benchmark. So the first person who get above 90 definitely get this one. For the other one, sperometer. And the first person can also choose whether he's getting the sperometer or micrometer screw gauge. This is completely up to you. But I will post you the vernier caliper for free for everybody. Okay, I think you understood this. Okay, now write the least count of uh, upper but screw instrument. It is not always micrometer, screw gauge, or what is called spirometer for any screw instrument, like that. Least count of any screw instrument. I told you it moves certain x distance. Certain x distance, that means one pitch for one cycle. Okay, have a good look at. So the equation is very simple. Least count equals to pitch over what? Number of divisions of circular scale, right? Circular scale. You divide pitch by number of divisions of circular scale. Copy this one. And the shorthand right equation, least count equals x over n. This is the shorthand notation. First we write the word equation after the shorthand notation. Then you ask me now, this one you get for free, right? I will keep the exam in a certain day, separate day from this class day. Like I catch certain day like poet day or something. I inform you beforehand, like at least 2 weeks earlier. Then I ask you to participate for the exam. Exam will be running almost like maximum of 1 hour and 30 minutes. Everybody should turn on the camera. It is not forceful exam. Only for those who would like to face the exam can face. And I will earlier inform the amount of content it may come, not the questions, amount of content. So you have to study as if you are facing to the level, get exam stress, exam phobia, and everything in this class, and get ready for that. Because you have to get ready for the exam by facing to the exam phobia, exam stress, that your writing speed, everything will be trained in this class. Okay, copy this one. Right. Now, let's find there are basically two types of there are basically two types of pitch and circular scale arrangements. Pitch and circular scale arrangements. Okay. Now in the first type, write that first type. Write it as first type. Okay. My both micrometer screw gauge as well as spirometer are the first type. Now write pitch length of 1 millimeter, pitch length of 1 millimeter, pitch length of 1 millimeter divided into how many parts? Pitch length of 1 millimeter divided into 100 equal parts. 100 equal parts. Okay, now you find the least count. I told you to use this equation. Least count equals to x over n. Tell me the answer. Very simple question. Very, very, very simple question. Find it and tell me the answer. Okay, Fashan, Anuhas. Yeah. Charaka. Shenuri. Ko. Others. Pabasara. Correct. I think is Steeny correct. Dulki correct. Isara correct. Okay. And also I have to tell you one important thing, right? Really correct. I'm taking like 2 minutes from your valuable time. I'm taking 2 minutes from your valuable time and give you a very important advice. So 2 days ago, one of my very best student actually asked me, sir, my school teacher told me that it is better to do in Sinhala medium than English medium because in the English medium, many of the students don't get good results. Yeah, there is the truth there. I will tell you everything. Why? Because in a local Sinhala medium, there are good teachers and bad teachers as well in the tuition field. So in the good teachers, they teach concepts. They always repeatedly teach you the concepts and feed you the brain, feed you to your brain. And there are like very popular but bad teachers also there. Popular good teachers are also there. Those who attend to the good teachers get really good results and ranks and everything. In English medium, there is a big problem. There were really good teachers. There were really good teachers before COVID. After COVID, those good teachers became really bad. How? I tell you why. Because in Sinhala medium, there are extremely rich people. In my school, when I was in Marshalla, well, I could see that extremely rich people are in Sinhala medium, and because that was a very big school, and in from other schools, most of them were like lower middle class students, but Sinhala medium, the extremely rich people also do A level because they have really access to good money. They just get private tutors to home and let the student to study. And the lower middle class, they have no option, they have to do A level. But in English medium I studied, they are not extremely rich even. They are not poor either. They are like upper middle class, but closer to the upper middle class, but just above middle class. So they have some amount of money, but not that extreme or that lower. So the students, when they get the exam stress, they just complain to their parents, Amma, this is very hard. shall I do a foundation? Then they have some amount of money, right? They say, okay, you can do. They do and get completely worse results. Why? Private universities are really good. I'm not telling no, but foundations will not give you enough IQ level to you to continue in a degree level. You are right. Even for A level, local, Edexcel, Cambridge, or whatever the A level, make your brain really tuned. You can study any further university level thing. But after doing a foundation, your level just drop and drop and drop. So the English medium local teachers are really found themselves in a hot mode. The very popular ones have like 200 to 300 students in a class. They don't like to see only 50 students remaining in the next class. They are really afraid because they earn like nearly like 1 million from a one class. In the following month, they are fear to earn only 200,000 from a class. But for me, only very handful of students are there in the class. Even in the next day, all of you are disappeared. I feel like, oh, okay, I'll do a group class and cover that up. I can cover this whole amount by doing a expensive group class. No problem. There are people who pay like 10,000 for one student. Like there are like 6 to 8 to 10 students in a one group. I can get even handy money than this class even. So I'm not afraid of losing. So that is why I am teaching the very deep concepts. In the Sinhala medium teachers, they know that lower middle class students never going to drop A level because they have no other option, they have no money. And the upper middle class students, they will hire many teachers to their own home and do it. That is the reason. So you are in the right place because I am not afraid of losing all the students even, but I will teach you the concepts. Without having concepts, my dear students, talk to your elder students, like 1 year older than you, 2 year older than you, who do A-level English medium. Those who go in for the popular ones, they try to keep the students only by solving very lighter questions, right? I also teach in a school. No? I just gave them really good questions and they were like helpless. They said like, they never done those questions. Why? They don't show because they are afraid of losing students. That is why good students in those classes even getting failed. It is not actually teachers' fault. Many of the students after COVID are not willing to take the challenges. I don't know why. It will completely depending on you where you study and how your gut level is, right? If you do English medium, you have many sources in your hand. Why? This is the last minute I'm taking because you can search in vast knowledge in the YouTube. In Sinhala medium, you have no chance. Right? There are no okay, Pehan. He said like he's going to stick with me for the until the end of the class. It doesn't matter. Okay. So the thing is, if you study with someone who just show you the way, he does the thing, and you assume as if you got the point, within 1 month, your knowledge of the previous lesson completely blank. If you would like, go there. That's the reason. But in Sinhala medium, there are many options because there are good teachers. They have already earned for like many generations for their wealth. No, they are not afraid, and the students have no choices. They learn whatever the hard points they teach. In English medium, there is a big problem, all because of the gutless students, not the teachers. I'm not blaming those teachers. So if you have a really good gut, if you have a really good study habits, English medium is the best because you are ready for becoming a global student, not only stay in Sri Lanka. Even you are staying in Sri Lanka, you can just be a global figure, right? Don't miss out the chance of doing English medium A level. If you are Tamil medium or Sinhala medium, will not help you in the university. Okay, that student asked me that thing. Even for my Piliyandala physical class, there was a one parent who came, like he had like sweating all over his face. Even that father, sir, mama රජයේ සේවකයෙක් මට මේ ගැන ලොකු තේරුමක් නැහැ. මම කියලා දුන්නා, okay, now check your son for 3 weeks. In that, after that, those 3 weeks, if he doesn't feel really fit, just please change the stream to the language to Sinhalese medium. But the student was a really good one. He's really smart. He said, like, sir, I will continue, but my father is afraid because other people has just fed his knowledge brain. So whatever your sir said was half truth, half false, right? Half truth means something like that happens. But don't worry, I get sure, I give you the confidence and everything. I will never teach like a kind of like cheap way. I teach you with the concepts. Without concept, you can't survive in the A-level. That is my logic. That is my vision. Okay, let's focus on to here. The first thing is 1 millimeter. You divide it into 100 equal parts. So your minimum reading of the least count is 0.01 millimeter. Everybody drop me the same answer. Very good. Copy this if you couldn't get it. Okay, students. Now let's move for the second type. Quickly. Second type. Second type. Now write the second type. Now write. There are screw instruments. There are screw instruments with least count of pitch scale. Pitch scale 0.5 millimeter. 0.5 millimeter. And 50. Okay, there are certain, yeah, I'm repeating, there are certain screw instruments with least count in the main scale or the pitch scale with 0.5 millimeter, and it is divided into 50 equal parts. 50 equal parts. Now find the least count and tell me very quickly. It will only take 10 seconds. Yes. Yet Fashan. The other student was Huda. I sent the parcel. Okay. Usan, yes. Correct. Others? Hello. Isara, correct. Henobi, correct. Okay. Rehan, correct. Pavani, correct. Okay, enough. Everybody got the correct answer. Now have a look at least count of the main scale is 0.5. You are going to divide this into 50. So when you just turn this into a equivalent fraction, in the equivalent fraction, this part becomes 1 again, 1 millimeter over 100. That means the final answer is 0.01 millimeter. Okay. So if you have a doubt that how would I convert this to an equivalent fraction, grade 7 thing, you have to multiply the thing in the same number of the numerator as well as denominator. I multiplied both by 2 and 1 over 100. That means 0.01 millimeter. I hope you understood it. That's it. Now write. It is obvious. It is obvious. It is obvious that screw instruments have a least count. Screw instruments have a least count that of 0.01 millimeter. Open a bracket and write 0.001 centimeter and close the bracket. This is the same. So now I am going to ask you very familiar question. Well, I am actually bringing you to certain familiar territory. What is it? Now I am asking, what is the measurable errorless length of a screw instrument? If you can find out the answer, tell me. I will wait only for like 20 seconds. No. Errorless. The smallest distance you can measure is 0.01. But I'm asking the errorless. Tejan is correct. Okay. Okay. Others? Pashan correct. Vidur Shana correct. Isara correct. Charaka correct. Hello. Okay. Write a subtopic. Write a subheading. The minimum errorless measurement. The minimum errorless measurement of a screw instrument. The minimum errorless measurement of a screw instrument. Okay. Errorless, huh? So we know one thing. For a meter ruler, it is 10 centimeter. Right. For a vernier caliper, it is 1 centimeter. Now we have to drop the margin even below because we have to measure something even smaller. How can I definitely do it? We have no other option. We have to drop the least count. We have dropped the least count to 0.01 millimeter. Now we have dropped the least count to 0.01 millimeter. Now the equation is, I think the top light is very annoying. But without that, you can't see the board. Don't know. Okay, next week, I'm definitely change the entire light setup because this is annoying for me. because I do 25 class and 24 class and all my revision classes in my that share screen. I never come to this premises even for those classes. But for your class, most of the students like the conventional whiteboard. If you also like that share screen method, so that's why I didn't focus many attention to this lighting setup. But I promise you in the next week, I will change all the lighting setup to more convenient way, because I got surprised actually. Normally, most of the students in my 25 batch and 24 batch really like the other board that I show you calculations in the last week, because in that board you can see the things clearly, you can do all the calculations clearly and stuff. But for some reason, these students requested me to stay in this board, so I have to develop the lighting setup. I'll definitely do it by the next week. Okay, students. Hello. Only for today, just adjust somewhat. Okay. So the brightness level just changing very dramatically. I will just change all the. Yeah, the graphic board with black background is really awesome. It is really obvious. You can see the many. I can see actually draw vernier scale and drag all over there and show you many multiple readings. There are many facilities are there. Who knows? Okay, might be the next generation change actually occurred in your batch. Who knows? Actually, the who knows that the 25 batch belongs to the previous generation and you belongs to another new generation. Who knows? Okay, there is equation percentage error equals to least count over the minimum reading into 100. We use this technique in the meter ruler, in the vernier caliper. Okay, Ramai. Now have a really good look at percentage error here is just 1%. This is the maximum tolerance for any reading. The least count we drop it to 0.01. The minimum reading RM by 100. So the percentage and percentage gone. The minimum reading is 0.01 into 100. That is millimeter. I forgot. Millimeter into 100. So the answer is 1 millimeter. The minimum measurable reading is 1 millimeter. Understand? Understand? I taught this a long time back. If you are asking, I will teach you. Long time back. But copy this one. Copy this all. In a meter ruler, see the least count is 1 millimeter. You can't see because the camera resolution in the zoom is not that accurate. So 1 millimeter. If you find your On real foot ruler, you can see it. The minimum reading is, least count is 1 millimeter. Now I am going to replace. Now I think you have copied this. I'm going to change this one here. It is 1 millimeter for the meter ruler. 1 millimeter. Right. Percentage sign and percentage sign gone. So when you cross multiply, it is going to be 1 millimeter multiplied by 100. That means the result becomes 100 millimeter. That means 10 centimeter is the least measurable length. If you measure anything smaller than that, percentage error will exceed 1%. That means false result in the readings. I explained this one 2 weeks ago. Okay. For the vernier caliper, I follow the same routine. So readings are really easier to take in this compared to vernier caliper. Very easy. Now write. Okay. How to take readings. How to take readings in micrometer screw gauge. Micrometer screw gauge. Okay. Now I will tell you how you are going to take readings in micrometer screw gauge. Have a really good look at. Now, right, there are two types of micrometer scales. There are two types of micrometer scales. Two types of micrometer scales. I have given you already. I'm not going to do any calculations. Have a good look at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Like this. 1 millimeter spacing. Scale with pitch of what? 1 millimeter. And the circular scale of n equals to 100. N equals to 100. That means there are 100 equal divisions. This is a one type. Okay. This is a one type. The other type is something like this. Have a good look at. So the 1 millimeter scale is as same as the above one. Okay. So these scientists are really cunning. If you draw another line like this, it is never going to be easy to read. Irreadable. So today itself, I did the same lesson to my Negombo physical class. Same lesson. And I realized that my vision power is way more powerful than most of the students in my class. They couldn't read this. What? Micrometer screw gauge is 1 millimeter line C1. They were telling like, sir, it is 3. Somebody say like 4, because they couldn't see the 1 millimeter line C1. So how can they see if you divide this again into 0.5, it is very impossible. I'm sure even I can't read. So for average people, it is very, very irreadable. Okay. You won't see this because glare is there, but it is 1 millimeter lines are there. Completely 1 millimeter lines. But this is not a good way. This is not a good way to do. But there are certain methods that scientists have developed to make the scale. Let me show you how. But these people marked 1 millimeter line with a space of 0.5. See how crafty that one is? Wonderful, no? Now I am going to ask you a question. I am going to point this with the ball. Okay. What is this line? Can you read this line? This red line. I'm showing. Very good. Vidursana and Fasan. Very good. Charaka, very good. Others? Hey, my hand is paining, man. Tell me. Senuri, correct. Hmm? Uh-uh. The Jan. Tejan. Wrong. Anuhas, correct. Okay, enough. Enough. Hammu. See, I will first read the main line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. These lines are 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5. Understood? Hey, I'm asking you. Understood? I'm asking you. Yes. Okay. I will point another line, another line, another line. Okay. What line is this? Don't tell me that is a tap line. Vidursana, you are like dynamite. Very good. Pavani, very good. Usan, very good. Insiluni, very good. Insiluni is like a mini Siluni. Charaka, very good. Pass, very good. Fatima, very good. Okay, enough. Now it is obvious for everybody. Draw this one even. Draw this one even. Now mark the pitch length. This one is the X. Pitch is 0.5 millimeter. And the circular scale come up with that one is n equals to 50. Copy that. Okay, dear students. Hello. I think you had enough time. I will give you another 20 seconds more. Copy this very quickly. So in the main tude, in the page number 19, as well as in the page number 17, you have these two really good looking diagrams of the micrometer screw gauge. Now write the subtopic, very big one. Parts of a micrometer screw gauge. Parts of a micrometer screw gauge. So I recommend you to draw this diagram. Okay. Those who didn't get the tube so far, you will probably receiving it by the day after tomorrow, or ask me for the PDF. I will share you the PDF of this one. You can just draw the diagram by looking at your screen. Now I will draw diagram to explain it only, but don't copy that diagram right now because it is time wasting. You just draw it at home. Please draw it. Don't avoid. Just keep the space for this wonderful diagram and draw it by yourself. I will. But not the all recordings. Only recordings will be given for this month. If you want to get the recordings for the previous month, you have to make the payments and get it. And that the reason is there are a few students, they are only watching the recordings in this class. They don't join to this class as a live students. So therefore, if I give the same recordings for someone for free, it is not fair. So I normally charge for the same charge as how I charge from them for the recordings. That is our institutional policy. This is an institute. This one I can give you. Okay. Now, let me just draw a certain micrometer screw gauge. Okay. Have a really good look at. And I am going to draw a certain main scale here. Zero line and the 45th line and the 5th line. Like this. And there is a certain part. And there is another part. Okay. Actually, this part can move to and fro. This is a still part. It doesn't move anywhere. Let me show you that again by this one repeatedly. So see, now see, you can see this part, the same part over here, move back when I rotate here. It goes back. It comes forward as I'm just going to move it, and finally it get tightly closed. Okay. This movable part we used to call as what? A spindle. Okay. Let me name anvil. Anvil, spindle, spindle, and look at this frame. What is the letter you can just remember when you see this thing? Huh? What is the English letter you can remember only looking at this part? That is C. So we used to call this part as C frame. C frame. Because this frame hold most of the parts. I am just going to actually detach this one. Mama dekata kadande yanni. See, now you can actually see this frame hold the anvil as well as this sleeve. So for why do we call it as a sleeve? See, you can see the other side even. It is a cylindrical part. For the outer surface of a cylindrical part, used to call as sleeve. Right? Shirt upper sleeve, folding sleeves. Understand? C frame. Can you see the internal? Is not that obviously clear, but in this side, wait. The interior of this part is resemblance to the threads of this nut. Okay, interior. And here you might see inside of this the screw. Actually, this is the bolt. This is the bolt. So this is the bolt like this. Okay, this is the nut like this. When you fix lock and nut, sorry, not bolt and nut, when you move it forward, you will see now here. See, now it does not move. So now I'm rotated, only one came out, two came out, three came out, four came out, five came out, six came out, 7, 8, 9, and 10. As you keep moving, it will move forward. Like in the same manner, I am going to fix this in. See, it goes forward. Now it has came in here. See, only I'm going to rotate one cycle. One line came out, distance of one line, two lines, three lines, four lines, five lines, six lines, seven lines, eight lines, nine lines, 10 lines. Exactly 1 centimeter just came out of this. Can you just understand this one? Huh? Hello? C frame and this long handle type of part we used to call sleeve. Sleeve. The scale written on the sleeve we used to call like main scale. Oh, oh. Why did I say oh? We can say it like sleeve scale. What? Sleeve scale. Sleeve scale. And this whole part is called thimble. Thimble. And this scale, we can say it like circular scale, no problem. Or we can say it like thimble scale. What scale? Thimble scale. And the other part, this separate part over there that you can hold and rotate, that part is called ratchet. Ratchet. R-A-T, wrong marker. R-A-T-C-H-E-T. Ratchet. Or thimble head. Thimble head. Thimble head. Okay. If you would like to draw this one directly, because this is hassle free, take a screenshot of this one and draw it later. Take a screenshot if you would like to draw this structure. Or my tute's structure, whatever. I have given enough time for you to take the screenshot. Okay. And there are two other parts. I forgot to mark. There is a part in my screw gauge. Actually, that part is missing. There is a part called lock screw. Lock key. Lock key. Lock key. If you are the eldest in your family, if you are a girl, if you are coming from very like rural decency from a family, they might call you lock key. Ne? So this is lock key. And there is another screw that is zero adjusting screw. Zero adjusting screw. That one is over here. See, I can put any screw and rotate this and adjust for the zero error. Okay, my dear students, copy this one quickly. No, sorry, take a screenshot or draw the one I gave you in the tube. Not now, at home. Okay. I think we learned very essential parts over there. Very essential and important parts over there. Didn't we? Didn't we? Now let me explain you all. So the name is already there, zero adjusting. If there is a zero error, you can adjust it until the zero error to go. Anvil and spindle together, that is where we keep the object we measure and get the reading. Let me show you. I am going to measure the diameter of this rubber wire. What I am going to do is, I am going to rotate this ratchet until these two in contact. You will hear something. See? Do you hear any sound? Do you hear any sound? What is the sound? What type of sound you hear? No? What type of sound you hear? Okay, I'm keeping it closer to the mic. See? What does that? Seriously, nothing? Oh, seriously? You might be in a very noisy area. Oh my God. Okay, again, nah? Don't you hear any tickling sound? Tick, 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 tick type of sound? Horrible now. Everybody had heard it. Okay. So we just, these two are to fix the object in between. Right. What does the lock key do? When you are about to take the reading, you hold the instrument picks with that and pursue you lock. In here, the locking key is not there. Once you lock, it does not move forward or backward. So you can take the reading peacefully. You can just read it peacefully. Oh my God. Like that. Okay. So the sleeve is the space, it provides space to main scale. It provides the space to main scale. Sleeve is the part, it provides the space to circular scale. See, circular scale. You can see the numbers written over there. Circular. And these grooves are to help to you to move it. And the ratchet play a very important part. What does the ratchet play? What part does the ratchet play? Huh? I told you, my dear, not to adjust the spindle actually, not easy moving. Once it in contact with the object, it let us know by emitting this sound. Try this time even your luck. Now I'm fixing it for my finger, right? You see, I will fix with my small finger. That's easier. Ow, it's really painful. Better to use the big finger. Don't you hear? This let me know now you have come to the destination. Stop it. Okay. This ratchet is the one has the mechanism of emitting the ticker sound for us to let know that I have come to take the readings. Understand? Hello? Hi. Now I'm logging it. Right, my dear students. Shall we take some readings? Okay. Also, wait. Wait. So there are, oh, shit. Now, in the page number 17, all the explanations are given for the parts and use of it. So C-frame. C-shape frame is identify the bigger rigid part that has both holding points of the job for object to measure. The size depends on the micrometer measuring range. C-frame increases as range expands to bigger. The main function is to provide basic structure of the micrometer to stationary anvil located at one end and movable spindle slides inward and outward to the other end of the C-frame. All the explanations are given there. with the functions. So please read it, that's enough. If you would like, keep some space to write it. I'm not spending time of giving you a very big 3-page longer note. It will cost our entire day. Okay, can you understand what I'm telling? Please don't wait for me to spoon feed you. Write if you want, write these things in your writing book or just read it from here. Because in the future, lessons are going to be really tough. We don't have time to waste. I told you, no, I am someone showing you the depth. I don't hide. Okay. Okay. Now let's quickly move on to readings. Let's take some readings. Now write how to read the main scale. Now write how to read the main scale. How to read the main scale. How to read the main scale. Okay. Now write the immediate line. The immediate line. The immediate line which is visible. Which is visible in front of the front edge of front edge of front edge of the thimble. Front edge of the thimble. Have a good look at. Now this is the front edge. See the edge of the thimble. So the main scale reading it is not visible here. Give me a 1 second. I will get use of my old this part. Okay. So if I just ask you this one as an indicator, what is the reading here? Main scale reading. What is the main scale reading? If I give, okay, that is 6. What is the reading here? That is 3. No, that is 2. That is 2. Okay. Now I'll draw something like this. See, now this act as if the 0 line. Other divisions. Okay. Now see, the 0 line and the 0 line covers. That means it is the initial position. Now I have moved to here. What is the reading of the main scale? What is the visible line? 1. What is the visible line? 2. What is the visible line? Yes. Now can you understand how to take the main scale reading? Now can you understand how to take the main scale reading? Yes. Obvious. Hard though. Easy. Easy, ne? I told you, no? That's it. Okay. Now I will draw few of the lines. Now try to take the readings of this. 1, 2, 3. Okay. After third line, this one has covered. Okay. What is the reading over here? Main scale reading in this diagram. What did you say? Ane sir, what? Something? Can you send me that message copied? You said something like Ane sir. ඔච්චර දුක්කලින් නැතුව අර ෂෙයා ස්ක්‍රීන් එකට ගියා නම් හරියනලු. නෑ ඉතින් ළමයි වැඩිපුර කැමති මේක. I will go to that share screen only for the question discussion. So there will be a question discussion. No? I will go to there. Okay. 1, 2, 3. The main scale reading is 3 millimeter. Copy this. 3 millimeter. Okay. Got it? Right? Okay. My A-level result. A double B. A is 4 physics. I did physical, not engineering. Okay. Right. Let's go for another reading of this one. I will erase this. I think everybody has just copied it. Now have a good look at. Okay. Now I'm going to do the same trick. 0 and 0 line overlap. What is this reading? What is this reading? Okay. What is this reading? Yeah, it is 6.5. What is this reading? 4.5. Very easy. Now I'll draw this one and you will just have to take the reading. What is the reading? Oh no, wait. What is the reading over here? The main scale reading. The main scale reading is what? 1, 2, 3, and 3.5. Sorry. Yeah, 3.5. 3.5 millimeters. Okay, students. Understood? 3.5. 1, 2, 3, and the 0.5 line, 3.5. That's great. Shall I erase? Okay, students. Now we have to take circular scale or the thimble scale reading. Now, right? Thimble scale reading. Thimble scale reading. Thimble scale reading. Now, right? Thimble scale reading. Nth line. What is it? Nth line. It can be any nth line. Main scale line. So the main scale basic line over there. So the meeting up of this main bar line of the main scale and the thimble scale line is known as the thimble scale reading. Any line of the thimble scale which is coinciding with the bar of the main scale line is thimble scale reading. So very easy to read. Circular scale reading. Just write it like a very simple notation. CSR. Circular scale reading. This is how you have to take n times least count. N times least count. N times least count. If n is equal to 25, if n equals to 25, how would be the reading? (25) times 0.01 millimeters. So the circular scale reading will be, what will be the circular scale reading now? 0.25 millimeter. Understand? Okay, students. That's enough. Okay, ne? Okay, students. Now we can go for the share screen and do kind of like good amount of questions in the on the spot worksheet I provided you. Okay. So are you ready to take share screen thingy right now and do? Because I sent you a on the spot live worksheet. Shall we? Hello? Okay. Stay there only for like 20 seconds for me to just get it arranged. Let's do and kill the paper. Can you remember? I just asked you to just read it. I don't know how many of you have read it already. Right? I don't know how many of you have read it already. It is micrometer screw gauge here. I just included all the knots. See, I just highlighted everything you wanted. On the thimble, there is a circular scale known as head scale, divided into 50 or 100 equal parts. I just gave you like a simple knot of pitch of the screw and the distance moved by the screw. See, number of lines of the full rotation given. Everything is included. See the parts like anvil, spindle, main scale, circular scale, C-frame, and the thimble and ratchet. So be frank and tell me how many of you just read the paper before joining to the class? Hmm? How many of you did? Just tell me, just like I did. Dad. Okay. Insulini, Papasara. Okay. Then who else? Fasan. Others. To be honest, I didn't. Very bad boy. Lydia, you did. She's someone joining for the first time. Even she has read it. And actually, yeah, you are suffering from fever. So I can just give you an excuse. Even you are joining to the class, it's a really good sign. Are you fine now or still suffering from fever? Right. Aha. I'm her bro typing. She's listening. That means bro and she's both learning together. Bro is a very little bro, no? Okay. Right. These are the theory parts. Two bros. Okay. Please count, and I just explained everything. Zero error. Okay. I would like to explain you about the zero error. Now, right, another subtopic. I'm going to teach you something like a theory now. Theory. Certain theory. So open up another subtopic. Zero error of screw gauge. Zero error of screw gauge. Zero error of screw gauge. Okay, Lamai, start writing like this. Definition, it's a very simple theory. It won't last like 5 minutes. Let's see whether you can learn things even on the share screen. Now write the definition. Presence of a of a reading on MSG. What is MSG? Micrometer screw gauge. Okay, MSG means not monosodium glutamate. It is micrometer screw gauge. When what? Spindle and anvil in touch with each other, in contact with each other. That means we are not ready to take any reading yet. We check the initial reading. Is there an initial reading? By just letting the anvil to in contact with spindle. See, anvil and the spindle. Okay, the anvil and the spindle are in touch with each other. So the reading we expect like this. The reading we expect like this zero line of the vernier scale, definitely in touch with the middle line of the main scale. So here there should be a reading, but here when we just in contact, the zero line of this one is nearly about to visible. Nearly about to visible. Okay. Nearly about to visible. That means something like this. If it is arranged like this way, it is called no zero error. No zero error. Let's go for the previous diagram. Let me enlarge it and show you. Now see the first diagram. No zero error. Zero line is nearly visible, but not visible. And this line and this first zero line are just in contact. We call this one with zero error is nil or no zero error. Understand? If you don't understand, let me know very quickly. Don't copy this diagram, it is complicated. Only copy these two diagrams. Only just copy these two diagrams. Okay, I will explain, no problem. Let me enlarge it one more time. Now have a really good look at. When you just leave the anvil and the spindle to touch each other, that means the reading should be 0. Reading should be 0 because we are not going to take any reading. In that way, the position of the micrometer screw gauge should be like this. 0 line of the thimble scale should be definitely in line with the middle line of the main scale, and the 0 line of the main scale is just about to see visible. Just about to visible, but you can't see it. Understand? Okay. Now let's see. Now, firstly, let others draw this. I think I gave you enough time. Now only take like one or no 20 seconds more. Okay, students, I think I gave you enough time. Gave you enough time. Now the positive 0 error. There is a certain thing like positive error. Let's see how the arrangement may look like. I will draw the 0 line here. I'll draw the thimble. This is not the 0th line. Now it is like 10th line. A 0 line, you can just see it is receding, and you can see the 15th line is appearing, something like that. In this position, actually, you can see another important thing. Now the 0 line of the main scale is just appearing. See, 0 line of the main scale is just appearing. That means this one, if I just draw it in the mega scale, again, you can see that this line has shifted to right. See, there is an error. That is a positive error. You are not about to take any reading. See, the anvil and spindle line touch. That means you have not put anything in between. But you can see there is a reading. It is weird, no? It is weird that this the 10th line is in contact. Can you understand? Draw this diagram as well as this one. You will understand. If you don't understand, let me know. students, if you couldn't understand, let me know. I will explain you one time, two time, three time until you to understand. Sir, how, sir? You are asking like no object. Then how 10 readings? Yes, good question. It can be a manufacturer defect. I will tell these all things in the end of the error lesson. I told you, no, you were not in my class by that time. I told them like 2 weeks ago. No, 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 no. It is not like that. You are telling like you should not buy that thing. No, no, no. It is not like that. Wait, wait, wait. I said like 2 weeks ago. I am going to teach. Yes. Errors 50% of the error calculations beforehand because it is really essential. I just explained you there is a thing called systematic error. This is also belongs to that. There is a thing called random error. So there is a thing called fractional error. There is a thing called percentage error. And percentage error is really important to understand these all conditions. So I taught. Now I just keep proceeding with the lesson. Once I finish the lesson, I will finish the rest of the 50%. Imagine like if I said beforehand, like there is a systematic error called zero error. It can be due to manufacturer error. You don't even know what is zero error, right? And it can be also due to, now you asked, you didn't put anything in between. I told you it can be a manufacturer error. And if you just enlarge this, and see, and you will see there are certain things like rust formed in between. I will explain you all of these in the end of the class. Sorry, end of this lesson. While the next 50% of this lesson be taught. The other one is covered with some amount of grease. You can't see with these things with your naked eye. But to this one, this small distance is catchable. Can you understand? That is how it may show. That is one of another reason it may show a reading before you are about to take reading. Understand? Hello? Hello? Okay, great. And Stanisla's brother might be asked that. Not Steny, I'm pretty sure. Asking like, we should not buy those things. It is not about that. Actually, it can be because of our bad handling of the instrument. Or just we can adjust the reading with what? Adjustment screw. Yes, definitely. පොඩි ළමෙක් අහපු ප්‍රශ්නයක් ඇහුවේ. Okay. Understand? Hmm. Now let's see how to take the reading. How to take the reading. It is something as if you are reading a normal reading. Positive error, you read it. Number of lines coincide multiplied by least count of the instrument. Very easy equation there. So let me show you the way how to take it. It is the 10th line. N equals to 10. Positive 10 times least count of the instrument is 0.01 millimeter. So the answer is positive 0.1 millimeter. That's it. That's completely it. Understand? Hello? Hello? Okay. Okay. Copy this. Copy this. Don't take more than 1 minute. Just copy it. Okay, just read it. Do it only within 1 minute. Yeah, I will tell you how to correct it. I will tell you how to correct it. I just still teaching you how to detect it. Don't worry, I will tell you how to remove it. Okay, students, I think I gave you more than enough time. Right, students? Now, right, how to remove zero error. How to remove positive zero error. Right. Before going for this, I will just go back to that height thingy. Height thingy. Imagine like you are just about to measure your own height. You are on the ground. And there is a scale. Show me a scale, a ruler. Okay. Imagine like this ruler is marked with 10 centimeters. Not okay. No. Imagine like in feet. This is just marked with feet. Okay, as if in feet. You are a really good 6 feet, 6 foot actually. Okay, you measure your height in a when the zero line of the scale is in touch with the ground, and you can measure your height as 6 feet, 6 foot. You are a 6 footer. It is tallying with your height. You are very satisfied. You have taken your height with no error. With what? With no error. Okay, can you understand it? Now this will lead you to understand this whole lesson. Na? So listen to this one very carefully. Let me make it short. Right. Now, one of your friend also measure his height. He seemed to be really elated. He's actually a kind of short guy, about 5 feet something. But the thing is, now this guy is just taking his height, even though he's not aware of that. He's from somewhere just above the ground level. Starting of the reading is on ground, but you are on top of like a uh, Coca-Cola case or something. He used to be a very short dude. Now he gets something like, oh my god, 6'4", 3". Wow. He's now really elated. Now, is that his reading correct? Is that his reading correct? No. There is a positive error. There is what? Positive error there. His actual reading should be this one. Actual reading. But he has a reading well over actual reading. What should you do? What should you do to remove this error? Suggest me anything. You have to subtract the error. You have to subtract the error. Don't think of positive or negative. Somehow you have to subtract the error. Here, how to take the actual reading? Actual reading, you have to subtract the reading by positive error. Okay, this is how you remove the positive zero error. I don't think there is a much better teaching method than this. Right? Understood, my dear students? Did everybody understood? Okay. Now let me show you for the negative zero error demonstration also from here. Right. Now your scale is still on the ground. No problem. Scale is here. But for some reason, you take your readings somewhere below because this was just attached to a certain steps on a staircase. You are just going to be one step below. Without having any aware of that, you are going to take your height. You are fair enough tall guy. Not too tall, but like 6 foot. You feel like your height is now about in the short range, what 5 feet 3 inch as a guy. Hmm. You feel really bad because you just feel no, I was a 6 footer. How come this happened? So this is your reading now. This is your reading now. There is an error. It should have been this level. The actual reading should be here. Actual reading should have been here. No. More than that, this will give you more idea than that. Wait. This is the reading. This should be the actual reading. Okay. What can you do to do this one? What can you do to recover this one? Add the error. Okay. But we used to remove error. We used to remove error. What? Tell me that. We used to remove the error. Remove means subtract. Have a good look at how I am going to do it. The actual reading is, have a good look at, reading minus, what type of error is this one, my dear students? It is a negative error, minus error. So this minus and minus automatically becomes plus. Understand? Write it like this way. More mathematically sound way. I don't think there is a much better way to express removal process of zero error than this in this whole world. If you want to, I will send this one in the PDF as a PDF at the end of the class. But for now, if you want to take a screenshot and draw it later, not now. Okay. Now how to remove the error? I'm going to come back to here. Actual reading is what? Reading minus positive error. Okay, that's it. I hope you understood. I am using a graphic tab. Okay, dear students. Let's quickly move on to negative zero error. Write a small subtopic. Negative zero error. Negative zero error. Minus E. Quickly. Now you can see, you can't actually see the zero line. Why? There is a reason. Actually, the zero line is now inside of this. That means this has moved to the right. I will show you in the mega scale. See, this has moved forward. That means what? It has gone inner. So it is a negative error, right? Imagine it shows like 42, line of 42, line of 42. Now there is a big doubt. Why? It cannot be, because you can still see some part of 0. Some part of 0, that means if it has gone 42 lines, that means more than half of the millimeter gone. So likes of the vernier caliper, 0 error. Can you remember the negative 0 error? How did we get? The same method. Same method. How? Tell me. Can you tell me the way of how get capital N minus simple N times least count? The same method. That is why I told you I just need to lay the foundation for the vernier caliper so hard. I have done it perfectly in the last week. So now you can learn any instrument very, very fast. Okay, for this one, see the negative error. What? 50 minus 42 times 0.01. 8 times 0.01 millimeter. So the answer is going to be minus 0.08 millimeter. Understand? That's it. That's done and dusted. Okay, done and dusted. Now I want to ask you a thing. How do you think? Would you like this share screen teaching for some time or not at all? If you don't like, I can just continue in the real board even. But remember one thing. This is better, but there are certain students who don't like me. That is the problem. But somehow, yeah, this is much better, because in this method we can save time. But unfortunately, students don't understand. In the regular board, I have to write it. I have to find the duster and erase it. It takes some time. For the question discussion, see, I will have to draw the question. But here, no need to draw this question even for some readings. I can just magnify and show you exact position. See? These facilities are not available on the board, but I will spend more time on the writing board for explanations, because you may just need someone animated on the screen. Screen for some critical parts, I will definitely come to this part and explain. From the next week onward, the whiteboard will be looking much better, right? Okay. This is very babies. I will do it. No, I will just ask you verbal answers. Now tell me, what is the reading of this main scale? Quickly tell me. What is the reading? Quickly, everybody. 6.5? No. It is just below it. It is just 6. Reading is just 6. What is this reading? Definitely 2.5. What is this reading now? This is very tricky. This is very, very tricky. No. Think more. Yes. See, it is an opposite direction. It is in the opposite direction, see. 5, 6, 7. Understand? So there are actually what? How many separations? 1, 2, 3, 4. 1, 2, 3, 4 separations. So each line carry 0 0.25, 0 0.25, 0 0.25, 0 0.25, like 0 0.5, 0 0.75, and next line. Understand? It is just on the first 0.25 line after 6. So in the papers, they actually test your IQ level. So these type of patterns you should understand. See, sometimes you get really weird questions like this. If I hide these questions from you, I'm doing a capital crime. That's why I'm telling you, I'm not afraid of losing students, but I want to show the reality. The reading is 6.25. Whatever unit is not marked, here. Now tell me what is the reading here. It is obvious, very simple. What is it? Hello? D? 3.5 millimeters. Okay. Okay. Read the following circular scales. What is it? It looks like the first line. 1 into 0.01. That means 0.01 millimeter. Very simple. Here. What is the part? What is the reading of this part? I'm asking about this part only. It is 24, 24th line. So the reading is 24 multiplied by 0.01 millimeters. So the answer will be 0.24 millimeter. Okay, right. I think we have done enough for this. So I have done until to 10:32. 10:32. Okay, 10:32. Now, do you need an interval or shall we continue? Whatever you would suggest, I will go along with the majority. Only 4 divisions where? This one here. Okay. No, 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 no. Yes. No, 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 no. 1, 2, 3, 4, 5. It is printing mistake, man. It is a printing mistake. So this line has just got here somehow. It should have been here, and this line should have been here. It was a printing mistake. Okay. It was a sheer printing mistake. Want an interval? Oh, continue. Okay, I want to get the what's again. I was looking at the other screen. No, 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 not a long interval. Not a long interval. I will give you very, very small interval. Small interval of 8 minutes. Don't leave the meeting. just quickly come. We have to discuss more of the questions, right? Just mute the meeting and just take 8-minute interval and quickly come. Maximum of 8 minutes. It is not eating interval. It is just refreshment, like washing your face and just eat something small and come. Not the main meal. No. Now let's take this reading very quickly. Here it is like 64. That means the reading is 64 times 0.01 millimeter. Reading is 0.64 millimeter. And here, have a good look at here. It is the 47th line. 47th. So the reading is 47 times 0.01 millimeter. So my reading is going to be 0.47 millimeters. Very simple. Okay, dear students. Okay. Now let's take readings. And after we have to go for the positive or negative. One student asked me during the interval, so how to identify these, whether positive or negative zero error? Don't worry, I'm going to explain everything today, every possible thing here. There are many more exercises to do. I am going to discuss all of these, and let's quickly go to the first of these, first set of these. So please do, don't do everything, huh? Don't do everything. Just do what I'm marking. Do A. Do E. Do C. It is also important. It's also important. And G. So the questions are A, C, E, G. A, C, E, G. There are 4 questions. This is your first time. So I will give you 8 minutes for you to do, 2 minutes for one question. And I'm going to turn on the timer. 8 minutes for first 4 questions. Okay, let's start quickly. Even though the time scale is running, I'm going to start the discussion. Everybody, pay your attention to here. Now, have a really good look at. You can clearly see the 12th line is just appearing over here. See, 12th line is just appearing. And it has only gone past, what, 16, 17, 18. This is the 18th line in the circular scale. This is the 12th line. How to take the reading? I told you, reading is main scale reading plus circular scale reading, right? So how to take it? 12 millimeter plus 18 multiplied by 0.01 millimeter. So your answer will be 12.18 millimeter. I think most of my students gave me the right answer. Okay. I think Stanisal's problem is her brother hadn't put the decimal places correctly. That's what. Right. Can you understand this part? If is there anyone who can't understand, just drop me a message. I'll explain one more time. If you understood it well, no problem. Okay, Lamai. B, I didn't ask you to do, but I will do it. There is a tricky part. Why? This is 49th line. See, no, I didn't ask you to do. 9th line, 9 millimeter plus 49 times 0.01. So it is going to be 9.49 millimeter. I did this as an additional part. Now I asked you to do the D1. In the D1, have a good look at 11, 12th and 12.5. What is the main scale reading? 12.5 millimeter. Okay. The 0, here it is nothing. 0. What does it suggest? Huh? What does it actually suggest? You can clearly see there is a big gap. There is a big gap here even. That means the next, it has just exactly come to the next line. It has exactly come to the next line. If there is no gap, that means if it is something like this, if it is exactly on this line, what would you take? You take it as 12.5 only. But here, the other line is just about to appear. That means you have to read it as 13, not like 12. Understand? 13.00 millimeter. Understood? That is a very tricky question. That's why I marked it. Very, very, very tricky one. If you don't understand this, ask me. Because in your term test, if you find something like this, you will just done. Okay. That's it. Here. 5, 6, sorry, 6 and 7. And the fourth line, what is it? 7.04 millimeter. Now have a good look at 12, 11, 12, 13. It is just covered exactly what? 11, 30 to 13.5. 13.5 millimeter plus 31 times 0.01. 13.81 millimeter. I think most of the students gave me the correct answer. That's it. Harini? It is exactly 11 o'clock. Let's continue with these questions. And actually, the whole micrometer screw gauge theory is done today. See, the question is very good one. What part you want me to explain? Sir, can you explain that? Okay, what part do you need me to explain? That's what I want to know. What part do you need me to explain? D question. Here. That means, see, there is a sufficient gap and no line visible, but there is a zero in the reading. Zero can appear exactly on top of another line, right? There is a sufficient gap even, right? That means it has rotated the full circle and gone for the next line. Understand? E question also, how does it came as 13.81? G question. Let me first of all check your answer for that one. Did you send me any answer for that? No, ne? You have not. You have not. Okay. You have not. I will explain you. I will explain you. Have a really good look at 11, 12, 13. You can see this line is just appearing. That means the main scale reading is 13.5 millimeter. The circular scale reading is, this is the 31st line. So the circular scale reading is 31 times 0.01. That means 0.31. You are going to add these two. I will show you with mathematically. 50 plus what? 31. 0.31. Now 1, 8, 0, and 3, 1. It is 3.81. Understand? That is not a big rocket science. My dear students, now listen to this one. The following micrometer screw gauges have their jaws closed firmly. That means you are not ready to take any reading. However, the read not exactly 0. determine the zero error and it is positive or negative. The students who ask me how to judge whether this is a positive or negative will get the treatment now. But actually, I don't want you to do everything. So, like in the previous case, I just need this one. I just need this one. I just need this one. ACF. Let's go for the other page and mark H and J. H and J. Okay. H and J. The numbers are like, I will write the numbers you need to do. A you have to do. C you have to do. From here, F you have to do. H you have to do. J you have to do. Do these 5 questions. I will give you maximum of 6 minutes for all 5. Students are sending me the answers already. Wow. Then I will reduce the timer. Only 4 minutes. Try. Only 4 minutes. Try. Wow. Fasan is like a rocket. Hmm. Others? Fasan, show me all the 6 answers. Sorry. Yeah. Okay. Tejaswin. Wow. Wonderful. Mm-hmm. I think some of the students tried and got kind of like mistaken there. Mistakes are there. Many mistakes are there. Huh? Can see many mistakes there. Let's see. You have 2 minutes more. Keep trying. I'm not in a rush. I'm not actually in a rush. Uh-huh. All the minus answers there. Wow. Keep trying, everybody. Lydia. Hmm. Mm-hmm. Okay. Okay. Last 5 seconds. I'm going to discuss now. Have a good look at now, students. A. Hmm. Now you can see the zero line is appearing more than half. So you have to determine it is like zero error, positive or negative. See, if you can see more than half zero line, it is more like a positive. That is not only the only criteria. If you can't see the zero line, more only very small part visible, that is more like a negative. That is not the only criteria, but that is a very strong criteria. So here you can see now it is like a positive error. 1, 2, 3, 4. The fourth line coincides. You read it like a normal reading. How? 4 times 0.01 millimeter. So the answer is a positive one, 0.04 millimeter. That is obvious. Most of the students sent me that answer. Now here, see, most of the part of the zero line is not visible. It is like only a very small part visible. That means obviously negative zero error. See, negative error, but it looks as if 47th line in line. It is unlikely to be happen. If the 48th line is gone, you can never see any zero line. In that case, it can also be 47th. If the zero line is completely vanished, that can be 47th as well. Have a good look at here. That's going to be 50 minus 47 times least count of 0.01 millimeter. Have a really good look at it. The error will be minus 3 times 0.01 millimeter. So your answer is what? 0.03 millimeter. It is a negative error. Understood? Understood this? Hello? Yeah. Uh, Now F. That is also more likely 44th line is in contact. Zero line is very rarely visible. Error is definitely a negative zero error. 50 minus 44 times 0.01. The answer is going to be minus 6 times 0.01 millimeter, 0.06 millimeter. That is a negative answer. So most of the students have done it correctly. Now look at H. It is 49. Very unlikely to be happen. 50 minus 49 times 0.01. The error is minus 1 into 0.01. So the answer is 0.01 millimeter a negative error. Okay. Now you may think J as a negative zero error. It is not a negative error, my dear. Reason is you can see the zero line very clearly, and this has gone past. So it is the real reading. It is not a negative error. Most of the students really wind up in this case. That is not your mistake because I didn't tell you the method before. So that is the reason. 46, 47, 48. You can directly take the reading because zero line is obviously visible, clearly visible. 48 by 0.01 millimeter. So the answer is 0.48 millimeter. Really, really very simple and easy to understand. Can you understand the J1? It is a positive error. It is not a negative error. Most of the students have wind it up. That is not your mistake. You didn't know before. I'm sure now you understand what is the real underlying reason behind it. Okay. Vidusana has correctly done it before. Lydia made the mistake. Senri also made a mistake. Let me check. Fasan also made the mistake. Tejaswin also. Only Vidusana had done it correctly. So the J question in A section is bit confusing. I think. Yeah. Okay. No, the next line is the more visible. No, that's why I round it up to 13. It is obviously there is a big gap. Okay, now right here. See, I will do the first one. The following micrometer screw gauges have zero errors as indicated in each case. Determine the actual reading in each gauge. Now see, 11, 12, 13, 14, 15. 15 and the circular line is 14. What is the reading? 15 plus 14 times 0.01. The reading is going to be 15.14 millimeter. Okay, now it is a positive error. Positive error means you have to subtract. The actual reading is 15.14 minus 0.23. Right. Once you cut, it becomes 1 here. 11 minus 20. 11 minus 20 means 1 minus 10 is 15.11. 14.91 millimeter. Understand? Like that, you can keep doing. Not all. I don't need all. Just read B, C, and D. Those three. For those three, I will only give you a time of 4 minutes. No, 1 minute for each enough. For sure. 1 minute for each is enough. Now I'm starting the timer. It is only 3 minutes. Do B, C, and D. That's enough. Oh shit. Vidursana. Vidursana killed it. Vidursana killed it. I don't know how did she manage it. Tejaswin also killed it. As said, repeat the question. Repeat the question mean I need you to do B, C, and D. Here. Senuri, wow. ඇතිනේ පුළුවන් කෙනා පටගාලා හැදුවා කියන්නේ අනිත් කෙනාට බෑ වෙන්න පුළුවන්. So it is useless to give you more time. So I'd better start. Then is all good. Okay. Enough. Now here, see, you have to use your eyes very well. See, you will never get enlarged things like this. So your regular eyesight, you have to trust. 5 and 6 line appear. Main scale reading is 6 millimeter. And the circular scale reading, it is 4th. CSR is 4 times 0.01 millimeter. Now what is it? The actual reading is going to be 6.04 millimeter. Now it is saying it is a negative zero error, right? It is a negative zero error. So you know how to take the actual reading is 6.04 minus 0.05. That means 6.09 millimeters. Okay, because that is a negative zero error. Okay, my dear students. Now this one, have a really good look at this one. Reading is 1, 2, 3, 3.5. Main scale reading is 3.5 millimeter. Circular scale reading is 30 times 0.01 millimeter. That means 0.3 millimeters. Your overall result is 3.8 millimeter. Now there is a negative zero error. See, negative of this much. Actual reading is 3.8 millimeter minus 0.47. So your answer will be what? 4.2 and 7, 4.27. That is very easy. That is very easy. Okay. Now let's go for the last one here. 12 millimeter line appear. Main scale reading is 12 millimeter, and the circular scale reading is 18 millimeter. 18 times 0.01 millimeter. Now what is the reading? 12 plus 0.18 millimeter. So what is the actual reading? Actual reading means you're reading 12.18. It is a negative error again. Minus 0.21. So that means you are going to add. So 38 and 1, 39. 12.39 millimeter. This is how the answers were ranging. Okay. Now it is completely, totally done. Okay. It's completely and totally done. So in the next week, I am going to finish. It is going to be a very, very long one than this. But I don't want to explain you the circular scale. Sorry, means the screw principle, because it is already done by taking time. But this instrument look very delicate and very small and very beautiful, may give you very big torture. Okay, may just give you very big torture. So you may need to read and watch something in Amrita Lab. So search that in YouTube, Amrita Lab, Indian one, Amrita Lab. Watch it before joining to the class. Amrita Lab, Sperometer. They have really good animations. In an animation, you can just get something like 20% to 30%. So high capacity students may understand 100%. That is an advantage. But the weakest student may get somewhere about 30% of the idea. When I teach you, it will be a really powerful boost, right? And also, I need you to get some more knowledge about equilateral triangle. So remember, find in your writing books or textbook of your O level and find out of the equilateral triangle, bisect of equilateral triangle, because the students may ask why this is 30 degree. There are students who used to ask me. I will explain you, but if you have forgotten equilateral triangle and the bisect of that, and the cos theta, how does the cos theta vary? I will teach you, but opposite side over adjacent side, these things you may need to have. And properties of right angle triangle as well as Pythagoras. These knowledge may need in the next week. Then we can completely do that in a one day. Can done within like 1 hour even, but in the very bad way. Like sir explain, you think like understood, but that is not true. In that way, I can do it in like 1 hour. But fully deeper meaning, deeper understanding, one day might not be enough. So be really faster. If you come up with this prerequisite knowledge, I can definitely teach you completely that you can never get tricked by any question in any A-level paper. Okay, let's wind up the class for today. It is exactly 11:30. Thank you very much for staying here. Okay. Yeah, Pehan told me the answer even. God bless you, my dear students. Bye. God bless you. Class is over. Okay. Bye.